Classification. So imagine a store. How do you know where to find the cereal or the milk? Are they in the same aisle? How is the store organized? Are all stores similar? Imagine your computer or your iPod. Are all of your songs and files in a single folder, or do you have them grouped in some way? Do you have favorite online stores that organize where you go to find things? All of that is classification, including how we classify vehicles or daffodils or even, Federation starships. So take a look at this picture. Are these scientists all describing the same thing? They were, but they were all using a different language. So scientists will use a common language to name organisms to reduce the amount of confusion. Classification is the arrangement of organisms into orderly groups based on their similarities, and we know this as taxonomy. This accurately and uniformly names organisms and prevents misnomers such as starfish or jellyfish that aren't really fish, and it uses the same language, Latin, for all names. Carolus Linnaeus was an 18th century taxonomist, and he classified organisms by their structure. And he developed the naming system that is still used today. He is called the father of taxonomy and developed the modern system of naming known as binomial nomenclature. Just say it with me, binomial nomenclature. It is a two-word name, which it has the genus and the species, conventionally written in italics and with the first letter of the first word, the genus name, capitalized, and the first letter of the second word, the species name, lowercase. Standardized naming. Again, binomial nomenclature. The genus and species name are italicized in print. You capitalize the genus but not the species, and you underline it when you're writing it on a piece of paper. So, for example, this bird's scientific name is Turdus migratorius, and this is the American robin. Everyone all over the world would be identified as Turdus migratorius, whereas its common name would be American robin, and that would not be as known to all people. Binomial nomenclature. Which two are more closely related? What do you think? If you said the polar bear and the grizzly bear, you're absolutely correct. Their genus names are the same, so they are more closely related than the panda bear. So the rules for naming. The International Code for Binomial Nomenclature contains the rules for naming organisms. All names must be approved by the International Naming Congress, the International Zoological Congress, and this prevents duplicated names. We do have classification groups that we fit things into, going from broad to very specific. A taxon is a category into which related organisms are placed. There is a hierarchy of groups from broadest to most specific. Domain, kingdom, phylum, class, order, family, genus, species is that hierarchy. So the domain, kingdom, phylum, class, order, family, genus, species. The domain is the broadest taxon. It will include the most. We have three domains. We have archaea, eukarya, and prokarya. And the species is the most specific. This is where we get down to the individuals. So just for an example of a mnemonic device that will help you remember this, dumb King Philip came over for gooseberry soup. Or dumb King Philip came over for green spaghetti. Or dumb King Philip called our family green snot. Whatever you want to use to remember it. But these are the taxon names. As you can see, we start at the top where it's very broad. Kingdom Animalia includes all animals, all types of animals, whereas species only includes the one type of animal. For humans, this is our classification and the characteristics of that classification, just in case you are wondering. A cladogram is a diagram that shows how organisms are related based on shared derived characteristics such as feathers, hairs, or scales. It shows where things developed as we move up the evolutionary tree. Everything that comes after a trait, the derived characteristic, such as the vertebral column, everything after that will have a vertebral column. Everything after amniotic eggs will have an amniotic egg. Everything after hair will have hair. But it will not. But the things before do not include it. Like salamanders don't have hair. They don't lay amniotic eggs. But they do have four-legged locomotion and jaw bones in a vertebral column. You see how that works? The derived characteristics are things that those things have, but they don't have the things that come after it. Dichotomous keying is used to identify organisms. Characteristics are given in pairs, and you read both characteristics and either go on to another set of characteristics or you identify the organism. And here is an example. For example, let's look at the first animal. Are there tentacles present or are tentacles absent? Well, we choose which one. Tentacles are present, so we go to 2. Does it have 8 tentacles or does it have more than 8? Well, I count 8. So 8 tentacles would be the octopus. And that's how dichotomous key works. I hope this was helpful. If you have any questions, let me know.